Okay, this is Algebra 2 Review 6-2. We'll just go over questions 1 through 2 real quick. Number 1 says, write a recursive rule for the exponential equation y equals 8 times 5/3 to the power of x. Well, what we need to do is, first of all, we need to remember that this right here, let's say this is y equals ab to the power of x. That's the basic form for an exponential equation. Your a is your starting point, and your b is your ratio. So to write it as a recursive, we first need the starting point. So when f is 0, y is 8. That's your starting point. Then for any given n, f, so f of n equals 5/3 times the previous n, f of n minus 1. And that's just page 5 of your notes, whatever. It's the first part of section 7.7 in your notes. All right. Number 2, same idea. It says use the given data to write an exponential rule. All right. Well, we already know it's exponential. They said it's exponential. So what we're going to do is we're going to do 147 divided by the previous, 1029 divided by the previous, and 147 divided by 21, I believe, is 7. And 1029 divided by 147 is also 7. And just to check it out, 7203 divided by 1029 is also 7. So these are all multiplied by 7. So therefore we know it's exponential because the ratio is the same. Okay, so we know our ratio, that's our b value. We also need our a value, that's the starting point. Well, we multiplied by 7 every time we went up. So if we divide by 7, 21 divided by 7 is 3. So when x is 0, y is 3. So you can write this one of two ways. You can write your exponential model, your explicit equation, which is the one we gave you up here. That would be y equals your starting point times 7 to the x. Or you could write it as a recursive, which is what we did on number 1. And that's when f is 0, it equals 3. And for any given f, so for f of n, it is 7 times f of the previous one, f of n minus 1. So either one of those are legitimate answers for this. Most people will probably give the recursive one, this one right here. That's what I'm kind of expecting, but you never know. So there you go. That's numbers 1 and 2.